Hello, this is Brian Mulhook. I'm going to show you how to do problem number 4 here.
What number are you at?
Okay, so yeah, let's get started. First we're going to draw our free body diagram.
You start behind the line. What? You start behind the line? Yeah.
And then so this is the ceiling here. Make that an extra thick line so we can tell that from the force vectors. And then we have our 6 kilogram weight right here. Draw that in. 6 kg. Kind of a bad 6. That's okay. Then there is a vector there. Here. This is horizontal. Then we have that one, and that is a 60-degree angle. So first off, we have the force of gravity down here, and that's pulling down. Then we have each of these is labeled. Let's see, 1, 2, and 3. And so we are trying to find a tension in each of these strings. So the force of tension, it's very easy for right off the bat for the first one. I'll just do that before Shannon takes over here. That's going to be just the normal force. So that's going to be the same as the force of gravity here. And that will be labeled Fn. Okay, I'm going to let Shannon take over now.
Okay, so next we realize that there's also force of tension in both of these, F of t and F of t. We just want to add that in. I don't know exactly how long they will be, but to find F of g, you do F of g equals the mass times acceleration, so 6 kilograms times negative 9.81 because it's gravity, and then that equals negative 58.86 newtons. So from that, since the normal force, or since there's equal and opposite forces, we will show this is actually F of t, because it's going to be the equal and opposite, so opposite of 58, so F of t equals 58.86 newtons. So that will be the tension for the string number 1. We'll just circle that. Next, you have to find the tension for string number 2, and we're going to do that by finding the x and y components of it. This is going to be force of 2y, and this will be this line right here is F of 2x. Since this is the only string going up and taking that tension of the gravity, since this one's horizontal, it's not taking any vertical tension away. The F2y is going to be 58.86 because it is taking all of the tension from that. So F2y equals 58.86, and that's this direction. It's taking that on. Next, we know that since this is a 90-degree angle, this is going to be 30 degrees right there. And we want to find all components of this triangle. So F2x we'll find by doing 30 degrees and then opposite over hypotenuse, or opposite over adjacent, so tangent. tangent of 30 degrees equals F2x over the adjacent side, which is 58.86 newtons. That comes out to be F2x equals 33.98 once you solve for F2x. And newtons. And then from there you can solve, so F2x equals 33.98 newtons.
But if I could comment real quickly, since this is the horizontal component of this triangle, and this line is horizontal, this is going to equal this third vector. So that's going to be the tension of 3. We'll do F tension 3 equals 33.98 newtons. And we can solve that from that. Okay.
Thank you, Brian. So, going on to find our number 2.
Of course, Shannon. Of course.
Going on to find number 2, that would be the hypotenuse of the triangle. So, all you need to do for that is we could use cosine or sine since we have both of these. And we're just going to use cosine. So cosine of 30 equals, cosine is adjacent over hypotenuse, so adjacent over the hypotenuse. So 58.86 newtons over the tension. So the force of tension for string 2. So F of T for string 2 is going to be equal to 67.96 newtons. Once you solve that out, so we found it for string 2, we found it for string 3, and over here for string 1, we can write it a little bit bigger. F of T for string 1 equals 58.86 newtons. So there you have it. We found the tensions of string 1, string 2, and string 3 for you.
Thanks for watching.